All right. 11-8 is basically talking about, are these three-dimensional objects that we're looking at, or these solids as it says here, are they going to be similar, congruent, or neither? Oh, there you go. And I think it's very easy to tell congruent, because then the two objects will be exactly the same. Similar, what you need is that they are the same object, or same shape, just different sizes, which means the parts have to be proportional. If they are, then you're fine. And it does have to be all parts. You can't just pick and choose which parts you're going to look at. So if you're on the side that has the border with the cylinders on it, we can take a look. And the one that I have on the right here, you can tell now that 18 is the diameter of that one. I think it's very hard to tell on yours. It looks like 18 is almost the radius on yours, but it is actually the diameter. And so what you would do is you would first take a look. I always would take a look for congruent first. Well, are these two cylinders? Well, at least they're both cylinders, right? So they've got a shot. Are they congruent? Well, no, because the height of the one on the left is 9, the one on the right is 27, so they are definitely not the exact same cylinder. But we would want to take a look. For example, you might want to say, well, the radius of this one over here is 3, and compare it to the radius of the other one. And what would be the radius of the other one? Well, 9. And then what you would do is take another measurement, and then if you do the height of this one, it is 9 over the height of that one is 27. Remember back to when we did proportions before, we had to set up and keep that pattern. And that's all you have to do. There's a lot of ways you could do these. One of the ways is just simplify all the fractions and see if they're the same thing. The one on the left simplifies to 1/3. Does the one on the right simplify to 1/3? It does. So that means we're good. They are proportional. The other way you could check, the way that we did it a lot of times the other way, is you take that one times that one, which is 81. Does it equal that number times that number? It does. The two numbers end up being the same. So is your answer going to be proportional? Is that what you're going to write down? No, you're going to say that these two solids are similar. And please be careful in the spelling of similar. I've seen a lot of people spell it similar. Okay, they throw another I in there, so be careful. Just spell it correct. It's not too difficult. Okay. So this one here, they are at least rectangular prisms, correct? So they have a shot of being the same. Well, you take a look at the measurements though, and they are not the same, so congruent is thrown out the window. A lot of people get this particular type wrong, because they take a look and they say, well, this one over here is 5, and this one's 6, so that works. It's 5 to 6. And then if I look here, this is 7 to 8. Well, that's good. And then this one again is 7 to 8. And so they say, well, it went up by 1 every time. And they say, good, it's proportional. But does 5/6 and 7/8, is that the same fraction? But could you see people wanting to say that, oh, it went up by 1, it's perfect? Well, no, because another way you could look is, well, that right there is 40, and that right there is 42. So are they proportional? No. So are they congruent? Most definitely not. Are they proportional, which means similar? No. And so your answer to this particular one is neither. Okay, it's not congruent, it's not similar. They look the same, but neither one of them. So neither. Some people struggle when they don't have a picture, which is why I gave you some of these. And you can draw a picture if you want. There's nothing wrong with that. And in fact, I will, just to review with you. So we'll say this is cone A, cone B. I just want to do it to review with you where all this information goes. So it says the radius is 4.3. That's pretty simple. And I believe the directions tell us that they are inches unless we're told otherwise. And so that'd be 4.3 inches. The radius of this one over here is 8.6. Where does height go? Actual height. Yeah, from the center to the vertex. So something maybe like that. You don't have to make it dashed like I did. And the height of this one's 12. And then the height of this one over here is 25. And how about slant height? Where does that go for a cone? Yeah, I see a lot of people kind of making the diagonal with your hand. And so the slant height of this one is 14.3 because it's this piece right here. Again, with a cone, you can draw it pretty much anywhere. But normally we stick to one of the sides, and the slant height here is 28.6. I realize some of you knew the answer to this one without drawing a picture. And if you can do that, it's fine. But I will caution you not to go too fast. So if you take a look right now, we could do 4.3 to 8.6 would be one way we could do that, right? Because sometimes it's a little harder to see if the fractions are the same. And then we would go 12 to 25, and then we would go 14.3 to 28.6. And the reason I'm spending so much time on this one is to try and keep you from making the most common mistakes. A lot of people say, okay, 4.3 to 8.6, that really does reduce to 1/2 if you don't see that, because the bottom's 2 times the one on the top, right? And then they look at, basically what they do is they look at these two, and they say, hey, those two are good. And so then they say it's similar. All of them have to be proportional. Does this middle one simplify down to 1/2? No. There's a few changes you can make. Obviously, if the 25 was a 24, it'd be fine. Or if the 12 was a 12.5, we would be fine. But they're not. One of them causes a problem, so similar is not an option. And so it's not congruent, it's not similar. This particular one is, again, neither. Okay. Your work is your explanation. Yep. I have, in many cases, been able to trick many people on a similar problem to this because they go too fast. I don't think we necessarily have to draw this picture. I think we're okay. The radius of cylinder A is 5.5, and same thing for cylinder B. Height 7.3 and 7.3. These two are most definitely congruent. Here's what happens. People get going too fast, and I'm pretty good with the computer. I can have them line things up anyways. And then some people get going too fast. I give them a very similar problem. I put that word in there instead, and people tell me congruent anyways. So basically, they just told me a cone was congruent to a cylinder. They're not even the same object, but they're congruent. Okay. So please take your time. This one, obviously, the way it was originally written is congruent. So why don't you go ahead and try this one on your own right now. And I think what we'll do is we'll just review quick how to draw this particular picture and where all the information goes. If you're drawing a period, remember that's one easy way to start. Bring it on down and connect it. Pretty simple. We'll say that this is the first one, and then the second one. And so we'll say right here the base width of 12 yards, base length 6 yards, height. Where does the height go for the pyramid again then? Yeah, straight down. Not coming down one of the faces, because what's that one called again if it slides down one of the faces? That's the slant height. We're just talking actual height, which would be in there, which is 8 yards. Again, I'm just reviewing. I'm assuming most of you got your answer without drawing a picture. Just checking with you and make sure that you know where everything goes. So this one's 24 yards. And there's a typo there, sorry about that. And we got 12 yards and 16 yards. So it's 12 to 24, 6 to 12, 8 to 16, and they are all yards, correct? That's another thing I could do to you. All of a sudden I'll say, oh, it's 16 feet on that second one for the height. If everything else was yards and then I put 16 feet, would that still be similar? No. But as it is written, are these two similar? Yes, they are. They all have the same ratio. Okay, so this one, similar. So watch out, I could get tricky. Or just very simply put slant height on one of them instead of height. Okay, so please take your time. All right. I hope you know that Jupiter is considerably larger than Earth. And apparently the diameter, it's approximately 11 times that of Earth. So how much greater is the surface area and volume? Is it just 11 times bigger? Think about it this way. If I took a softball, and then we take one of those big beach balls that we were kind of talking about earlier, obviously the beach ball is bigger, correct? Maybe, what do you think, 2 or 3 times bigger? Is the surface area of that beach ball only 2 or 3 times bigger? And is the volume only 2 or 3 times bigger? No. Here's what I look at it is. I look at diameter as being a one-dimensional measurement. Because if I were giving you a diameter, which would be inches or meters or yards, or in this case probably miles, correct? It's not miles squared, it's not miles cubed, it's just miles. So I look at diameter, perimeter, height, one of the sides, all as one-dimensional measurements. And according to this, if I do Earth over Jupiter, I would do 1 to 11. Do you agree that makes the diameter 11 times bigger? Isn't that the easiest way to do it? Is it the only way? No. But it's the easiest. So that's one dimension. So one dimension. Once we go to surface area, it's not miles anymore. It's going to be miles squared. So how many dimensions are we talking about? 2. So this is more of a two-dimensional measurement. So what you have to do is take the one-dimensional measurement, which was 1 to 11 in this case, and do what to it? Not double, square it. Because your label would be miles squared. Well, with fractions, it's very simple. You just square the numerator and square the denominator. Well, what is 1 squared? 1. What's 11 squared? 121. What does that mean? That the surface area of Jupiter is how many times the surface area of Earth? 121 times the surface area of Earth. The ratio will be 1 to 121. Okay. Or in other words, for every square mile we have, they have 121 square miles. Well, it said surface area. Well, that's good. How about volume? What dimension are we talking about now? Third, because it'd be miles cubed. And so this is kind of the third dimension that we're talking about. So you take your one dimension that you had, which was 1 to 11 was your dimension 1, and this day you don't square it, you cube it. Well, luckily, 1 cubed is still just 1. And I'll show you a little trick with 11s here in a second. But 11 to the third, what's that mean? That means, okay, it is a palindrome, not what I was looking for, but yes, they are palindromic. That means the volume of Jupiter is 1,331 times the volume of Earth. Okay? I guaranteed you a little trick. Do you agree right here was just 11 times 11? Okay. If you multiply by 11s, there is a nice little trick. I'm going to take this times 11 to actually get to that one, right? You put the first number down, you put the last number down. Add those two numbers together. Add those two numbers together. So if you take it times 11 again, if you had to, it'd be good job. Somebody told me 4. So yeah, last hour. Okay. That only works with 11s. Don't try that with something else. So in other words, the volume of Jupiter, 1,331 times the volume of Earth. I'd say seeing Earth is just a little bit bigger than that speck that happens to be in the picture of Jupiter. Actually, this little spot right there, that could be a storm or something, is bigger than Earth. All right, so. Okay. Okay, any questions?